This is how a serial key generation algorithm can be found in a software application. If you don't know what a key generator is, here's an example. This was from Razer 1911. I believe they were founded in Norway. It's a very old group, and back in the days they were very active in the cracking scene, and they have developed also key generators like this one. This was for Call of Duty 5, and when you click on generate CD key, it will just generate a key that you can then use to install the program. And every program that is checking for a serial key, there's an algorithm that is checking if your serial key is correct. And what you can do is you can try to analyze the program, try to find the algorithm in the program. Then you need to figure out how everything works, and then you can create your own or develop your own CD key generator. I've developed also a simple application that asks for serial number. So when I just enter some values, I print a message invalid serial number, and when I enter these letters, print a message invalid input, and a combination of letters and numbers will also print a message invalid input. So for now, we can assume that the program expects a numeric serial key, and the string is interesting. Invalid serial number. The strings are not encrypted. I have not encrypted the strings in this program. So what we can do now is we can load the program in Ghidra. Then I click on search, and then for strings we can keep these settings. Here we can see a lot of strings, and now if we will just look for interesting strings like this one, enter serial number, invalid input, the serial number is correct, invalid serial number, and the most interesting string for now is this one, serial number is correct, and this is the address, and here's a string. So this address just holds a string. Here's a reference, and when I click on this one, then we can see where the program accesses string, and here it just loads the address of the variable to RDX, and then it calls a function, and this function will most likely just print this string. On the right hand side we can see everything in C. So Ghidra tries to translate the assembly code to C, and I can click on the C commands, and then we can see which assembly instruction corresponds to the C code. And this block is interesting, and I click on this one. Oh, that was not correct. Okay, what's this one? And here we can see the message invalid serial number, and here we can see the message the serial number is correct. And if I click now through the C instructions, or okay, now let's just start from here. This message in this block, the message gets printed that the serial number is invalid, and what we can see here, here's a if, and this is the end. And inside of this if condition, we can see this loop. It's a do while loop, and let's just click through the C code and take a look at the assembly code. Here we can see the message invalid input. And here we can see another loop. This is an algorithm. And this is now the interesting part. Okay, so it will check if the variable alpha5 holds the value 3. When it holds this value, then it goes in this block. And if not, then we will go into this area. And we know already, here we get the message invalid serial number. So the variable alpha5 needs to have the value 3. Otherwise, we will see this message invalid serial number. Okay, what we can do now is to verify if that is really correct. Here's the start, CMP EDX3. Here we can see the string, the serial number is correct. And yeah, when EDX is 3, then we will get this message. Serial number is correct. Okay, now we need to figure out how alpha5 is getting any values. So I will just go up a little bit. Here's a while loop. This is I46, PB47, and then we can see alpha5 equal alpha5 plus, and then this command. Now it would be nice to know what alpha5, what kind of value it is holding. So we'll go up a little bit, and here we can see that alpha5 is 0. Here it is, x or edx, edx. So this will just set the value of the edx register to 0, and alpha5, it will basically just be the value or the register edx. But yeah, at first I will go through the C code, and this is already basically the whole algorithm. Or not everything, but the most important part. Yeah, so alpha5 holds the value 0 plus this one. This is a negation symbol, this one. And this address will hold the input. So when we input any serial number in the program, this variable will receive the data. This one is just AND, and we have a 1. So what is happening here is the data in this variable gets negated, and the result of that is then saved also again in this variable, and then AND operation with a value 1 is executed on this variable, and the result of this operation gets then converted into an unsigned integer, and the result of this operation plus 0 in this case gets back to this variable. Here we can see pb_7 equal pb_7 plus 1. So this means we will just point to the next value in our input sequence. Alpha equal alpha plus 1 plus minus 1, so it will just decrease the value of the variable by 1. Then it would be interesting to see what kind of value this is holding. maybe we can try to find out. You can see alpha equal 1 stack 20. Okay, here is 0. I can see it for now, but never mind, it's not so important, because we can investigate the program also in x64dbg, but for now I will just go through the assembly code and let's see where the algorithm compares the value of edx, and this is here. Okay, so when edx holds the value 3, this jump will not get executed, and that means it will print the string, the serial number is correct. And what we can see here is now when edx is not 3, then it will jump to this address, and then it will print the message invalid serial number. Okay, then let's go back to this one to see emp edx3. What we can see here, there's a jump instruction, and it jumps to this address. So this is a block of the algorithm, and now we can investigate how it works. Here we can see move zx, eax, byte pointer, rsi. RSI hold it points to address, and this address is holding our input data. Okay, and what is move zx doing? Let's say RSI holds the value 234. And let's say that this is eax, so eax is just holding these bytes. Then we have this instruction move zx, eax, byte pointer, RSI, and what it is doing now, it will at first it will move set all the values in eax to 0, and then it will move the first byte from the address where R is pointing to the AL register. So AL would be this one, readers 2. And if we would have something like this, then it would look like this. It would just change. So the 7 would become a 2 because it has moved the first byte from where RSI is pointing to. So RSI points to address. This address holds a value, and this is the first value at this address, and this value gets moved to AL. But yeah, move eax, it will not manipulate or change this data. Okay, then we are here. The not instruction, that's a negation. For example, if we have something like this in binary, and if we negate the bits, so the 1 becomes a 0, this 0 becomes a 1, this 1 becomes a 0, and this 0 becomes a 1, and this is a negation. And then we have this instruction and AL1. Let's stick to this example. So AL would be, so it would hold this this data. And now we execute the AND operation. So 0 and 0 is 0, 1 and 0 is 0, 0 and 0 is 0, 1 and 1 is 1, and that means AL is 1. Then removes data from AL to EAX, but in this case it will not change anything, so AL will be it will just be 1. And then we have this command, and it just adds the data from EAX plus EDX, and it saves the result also in EDX. And yeah, EDX holds the value 0. We can already see the XOR instruction, so this will just set all the data in EDX to 0. And then we have this command, inc RSI. It will just point to the next value in our input sequence. And we have this one, decrease R8. So it will just decrease the value in R8 by 1. Maybe you can take a quick look again in the assembly, but maybe you can see it. Here it's getting a value to R8. Okay, but let's continue here. So, and okay, R8 gets decreased by 1. And when R8 is 0, then it will set the 0 flag to 1. And that means if that happens, this jump will not get executed anymore. And yeah, it will go to this command to check if EDX is 3. And when EDX holds the value 3, then it will go to this message. Yeah, maybe someone knows already what's going on here. This is basically a modulo instruction. So that means it's checking in this case if a value is even or not. For example, if we have the value 4, and if you want to know if it's an even value or not, then we can say 4 modulo 2, and the result will be 0. And let's take the 7. 7 is not even. 7 modulo 2 is 1. And why is this the case? When we take the 7 divided by 2, we get this result. And now just ignore the data, the numbers after the comma. So just focus on the 3. And then we will just calculate 3 times 2. That's 6. And 7 minus 6 is 1. So this is rest. And yes, this is just calculating the rest basically. Yeah, you can use it to check if a number is even or not. And now I will open the program in x64dbg. And let's see where the algorithm starts. It's here, this address. Okay, here's the address, but we can't use this address, so it would be invalid. What we need to do now is we need to calculate an offset. So in order to do that, you will just click here on display memory map, and here we can see where the module starts. So I will just copy this address, and okay, that was too much. And this is the address where the algorithm starts, minus address of your module. This will point to an offset, and then we can use this offset and add it to the base, that's the base address where the module and x64dbg starts. Okay, at first we will calculate the address, and this is offset 16C0. Now we will go to x64 and click a memory map, and here we can copy the address. This is the start of the module, and this plus 16C0, this will lead to the start of the algorithm. So I will make a comment. Start of the algorithm, and we know already where the end is, and that's here. And where is it? Here it is. Okay, this is the end of the algorithm. I will set a breakpoint. Let's enter a value, 2, 3, 4. And now we can also take a look at the R8 register. So it holds the value 3. So our serial number should be 3 characters long. And now let's start to analyze the program. Here we can see RSI. This is RSI. It points to this address, to this address, and this address is holding this value 2, 3, 4. So after executing this command, EAX, or RAX in this case here, it will hold the value 1. No, sorry, it would hold, of course, the value 2. And yeah, it's basically, yeah, it will go, of course, in IL, because it's just a byte value. And I execute it, and here you can see the 2 in ASCII and 32 in hex. And we have the not operation now, so it will negate the bits, and it becomes 9 CD. Then we will execute the AND operation with a value of 1, and we get the value 1. Now the next step, okay, this will change nothing in this case now. So AX or AL, it will stay at 1. And now we have this operation at EDX plus EX, and RDX is 0. And yeah, 0 plus 1 is of course just 1. And the result goes to EX. Here we can see it. Or DL in this case now. in RSI. So RSI will then point to the next value in the string. So it will point to the 3. And we will decrease R8 by 1. So this will be 2. And since the 0 flag is not set, it's still 0. We will jump back to the start of the algorithm, and now we will do the same just with the number 3. So number 3 goes to AL. Now it's 3. And we negate the data. It's CC. And now we run the AND operation. And it goes to 0. Move that X, X, AL, of course. It will not change anything. And this is now the important part here. At EDX EAX, we know already EAX where AL holds the value 0 plus EDX. EDX holds the value 1. So yeah, nothing, it will not change anything. Then we point to the next value in the string, degrees R8, and we know already the serial key. The serial key will only be valid when EDX is 3, but in this case EDX it didn't got increased with a number 3. So number 3 is not a valid value for the serial number. So the serial number is already incorrect, but let's just continue with the value 4 in this case. So yeah, X. So we'll just go to 4. Here it is, 4. And negates the value. And it runs AND operation. And again, nothing will change. And now we can see EDX. EDX is holding 1. EAX is holding 1. So RDX, where the L will become 2. No, it's 2. And so now we will just point to the null terminator, and it decreases R8 by 1. Here we can see the 0 flag, it's still 0. And I will just execute operation, and the 0 flag goes to 1, and that means it will not execute this jump anymore. So it will not jump back to the start of the algorithm. Now we check if EDX is 3. Of course, in this case, it's not 3. And then it will jump to this this command or address, and yeah, I'll just let it run, and we can see invalid serial number. Okay, so the serial number is only valid when the value is even. We can enter values from 0 to 9 that are even. These are the valid values that we can use, and I will execute everything with a valid number. So valid would be 2, 4, 8. All these numbers are even. And I will quickly go through the program. We can see RDX is 1. Now I check this number, the 4. And RDX gets increased again. It's 2 now. Next value, here it's 8. Now we're checking if the 8 is even. And R8 is 0. The 0 flag goes up to 1. And it will not execute this jump. And now it will print a message that the serial number is correct. And yes, that is how the algorithm is working. And now I will show you the C code, or C++ in this case. Yeah, here's the start. You can enter a serial number, then it will check if the number is then it will check if the input is a number, and then it goes to the check serial number algorithm. So this is the whole algorithm already, and here we can see also the check if counter is equal to 3, then this function will return the value true. And yeah, counter is basically this alpha 5 equals 3, so here's a comparison. And this is just this one. Yeah, what we can do now is, or what I've done already, this is a key generator, so it will just check the numbers from 0 to 9, and it will save all the even numbers in numbers, and this is then just the algorithm for printing the serial key. Here you can see these values are these are the valid values, and now press enter, and it generates all the keys. And what we can do now is, let's say, take this one for 08, and since serial number is correct, this one 460. So these are all valid serial numbers, and yeah, this is how it works. I will put the key generator and the serial check and also the binary file for the serial check program in a GitHub repository, and I will put the link in the comment section. And that was everything for now.